Good afternoon, guys. Today we're going to go over 8.2. It's a pretty simple and straightforward chapter. There are a couple of old definitions you're going to just view in a different manner, but you should know them already. So there's only one new thing we're going to look at, which is example 4. Now today from 8.2, we're going to go from example 1 through example 4. Then we're going to finish off the section tomorrow. Now in example 1, it says express the vector in component form. Now, all that component form is ending up with pretty much a rectangular coordinate, an A and a B. Now, the way to do this is the following. In order to find the first item, you're gonna do x2 minus x1. In order to find the second component, y2 minus y1. For example, if they tell me a particular vector begins at 1, 2 and ends at 3, 5, and then they say, please write it in component form, all you have to do is x2 minus x1, y2 minus y1. 3 minus 1 is 2, 5 minus 2 is 3. This is the representation of this vector in component form. That's it. That's all you have to do for example 1. Again, if they ever tell you to express a vector in component form, that is all you do. Now let's go over example 2. In example 2, you can be given two different scenarios. Now for example 2, they're asking you to find the magnitude of the vector. The magnitude. So let's see. If I have a vector that is broken down in this component and this component. Those are my components. A vector going this way and a vector going this way. Would the magnitude not be this? That would be the magnitude. So there's two ways to work this problem. If they give you the component form, x and y, or a and b, if they give you the component form, say they give you this, and they tell you to find the magnitude of that vector, let's think a bit. Does this not look like a right triangle, right there? And would this not be the hypotenuse? So if they give you the component form, all you have to do is Pythagorean theorem to find the hypotenuse. A squared plus b squared, and the square root of that. That's going to be your magnitude. So that's what happens when they give you component form. Now let's say instead of component form, they give you the initial point and the end point. Now they're not giving you your x and your y. They're telling you that this point is 3, 5, and this point is 5, 8. If I want to find the magnitude from this point to this point, would that be straight up not the distance formula? Because remember, we're working in a coordinate plane here. So if they give you the initial and the terminal point straight up, you're going to use the distance formula. That's going to give you the magnitude. If they give you the component form, Pythagorean theorem. That's all you have to do for example 2. Those are the only two possible outcomes. You're either going to use the distance formula if they give you the initial and the terminal point, or you're going to use Pythagorean theorem if they give you the component form. That's it for example 2. Again, today's class is going to be pretty short and very useful for SATs, math tests, etc., etc. It's very educational. Now, let's go over example 3. Example 3 is a continuation of what we worked on last class, which is vector operations. We're going to work with addition, subtraction, and scaling. So in example 3, they tell me in the book on page 493 that W is, and again, they're giving me various component forms. you should know this as component form. This is not a coordinate, but an addition of component vectors. Okay, so that's W is negative 4 comma 1, Y is 2 comma 5, and Z is negative 3 comma 0. Okay. Now, if they give me, for example A, W plus Y, all we have to do is join the X's and join the Y's over component form. So my W is negative 4 plus my Y, which is 2. That's going to be the X, because I added both X's. And now for my Y component, I'm going to add the Y part of W, which is 1, and the Y part of Y, which is 5. So again, this would be X1, this would be X2, this would be Y1, this would be Y2. You can confirm right here. Now, when I add all of this, I end up with negative 2 comma 6. That is the answer to example A. Pretty much just add the components that they're giving you. Let's go over example 2. Z minus 2Y. Now I'm going to be scaling Y and then subtracting it from Z. So let's begin. My X1, it's just plain old negative 3. Now since this is a minus, I have to put minus here and then you include the term, because the sign might change. Now when you multiply Y by 2, because I already applied the negative here, it's going to be a 4, comma, and now I have Z, which is 0, minus 2 times 5, which is 10. When I add all of this, I get negative 7, comma, negative 10. That's it. I scaled and multiplied. Now there are two ways to do this. You can either write the first term and then scale the components they're giving you by negative 2, or you can do it how I did. If it's negative, you just write negative sign, and then you just multiply whatever value they give you and you plug it in. That's personally how I do it, but you can do it both ways. It's perfectly fine. So either you put the negatives and then you multiply only by 2 and that number gets plugged in here, or you multiply the number by negative 2. Negative 2 times 2, negative 4. Negative 2 times 5, negative 10. I just like writing my signs beforehand, but either way it's fine. So that would be, and again, that would be example 3, the B. Now let's go over example 3. That's pretty much it. I'm going to do 3A just in case. 3A says 4W plus Z. And actually, let's do example, the guided practice C, which is slightly more complex. 2W plus 4Y minus Z. Oh, Dios mío, profe, they're giving me 3 things. Now, that's fine. Just do it one at a time. Since these are addition and subtraction according to PEMDAS, order doesn't matter. So let's begin. I'm going to multiply. What I'm going to do is I'm going to scale everything and then just join it. So 2 times W will turn this into negative 4, 2, plus 4 times Y, 8, 20, minus Z. I'm just going to change the sign. I'm going to add, but I'm going to change the sign inside the parentheses. So this becomes 3 comma 0. And again, we're using the same component vectors. So again, to verify, I scaled my W, it becomes this, multiplied by 2. I scale my Y, it becomes this. Now I don't multiply by anything, but I do have to change the sign of my Z because I'm subtracting it, and I can just change this to a plus and change the signs inside the parentheses. Now that I have scaled everything, I'm just going to combine like terms. Negative 4 plus 8 is 4, plus 3 is 7, 2 plus 20, 22 plus 0, 22. That would be the answer for 3C, the guiding practice for example 3. Again, to recap, example 1, it's just turning a vector into component and giving me the component form. Example 2 was finding the magnitude, either using the distance formula or Pythagorean theorem if you're given the component form. Example 3 was straight up operations, addition, subtraction, and scaling. Now, example 4 is pretty much the only new thing we're going to see here. And we're going to look at a new term called unit vector. Now, you guys remember that the unit circle is a circle with a radius of 1. So the unit circle is a vector, or the unit vector, I'm sorry, unit circle, a circle with a radius of 1. The unit vector is a vector with a magnitude of 1. A magnitude, okay? Now, how do we represent the unit vector? We use a lowercase u. And the way we find the unit vector is pretty much using this formula, which is the exact same thing in the book as this. All they did was remove this numerator here and substitute it for a 1. Some people prefer using this form. Either way is fine. I recommend you use this one because it's how they use it in the book. And pretty much just go ahead and use this one. Now, even though it might look complex, it's very simple and it's a series of steps you guys have done multiple different ways. Now, let's use this formula. Note that this is the letter V and this is also the letter V. The only difference is that they're giving me, you know, this whole absolute value thing. If you look at example 3, you will note that in example 3, the formulas for both the terminal and initial, way to find the magnitude and also the component form is this. So in the denominator, we're going to use either the distance formula or Pythagorean theorem to find that value. And here, since I don't have the absolute value, it's going to be straight up the exact same numbers. Let's do the example in the book. In the book, they're giving me this. V equals -2, 3. So since they're only giving me 1, you can tell that it's component form. If they were to tell me the initial and the ending or the terminal, you'd have to use distance formula. Here, since they're giving me component formula, I'm going to be using this. That's going to be the absolute value of V. So when I substitute, again, I'm going to substitute the one with the absolute value, which will always be in the denominator, with square root of a squared plus b squared, which is Pythagorean identity. For this V, I'm just going to open a parentheses and put these exact same two numbers. No problem there. Okay. Don't need this anymore. Now, the way to work these problems is always work the fraction part first. Always. Just do it. A was -2. A was -2 and B was 3. So when I plug it in here, I'm going to end up with square root of -2 squared plus 3 squared, and here -2, 3. -2 squared is 4, 3 squared is 9, 4 plus 9 is 13. So I have the square root of 13. If it doesn't give you a perfect root, just leave it expressed as a radical. So I have 1 over 13, -2, 3. All that we have to do now is rationalize. So I'm going to multiply both the numerator. Again, for the people who don't recall rationalization, I have this. The whole point is to get rid of the radical in the denominator. If you multiply anything by 1, it doesn't change. You multiply 3 times 1, 3, it doesn't change. So this fraction represents the number 1, because any number divided by itself is 1. Now when you multiply this fraction times this fraction, which is representing 1, 1 times square root of 13 is square root of 13. Square root of 13 times square root of 13 is square root of 13. squared, the square cancels out the root, and you're left with this expression, square root of 13 over 13, and then you have these two numbers, which are the v's that were left over here. Now, pretty simple. Multiply this times this, comma, multiply this times this. Done. That's all you have to do. That's the unit vector. Initial, terminal. Nothing else needs to be done. Again, remember, the only thing you have to do is use what you learned in example 2 for the denominator. If they give you component form, Pythagorean theorem. If they give you an initial and a terminal, well, pretty much they're giving you the vector, so you don't have to do anything. But just remember to use Pythagorean theorem in the denominator. Now again, most of the time you're going to end up with a square root that doesn't have a perfect root, so just leave it expressed as a radical and rationalized. Then you multiply the numerator times your x and the numerator times your y to get your x and y values. That's pretty much the class. If you have any questions about these examples, go ahead and let me know. We'll set up a video conference call. I'm going to set up the homework right now. Now for homework, please do one from the exercises, 1-4, which is finding the component form. You're also going to do 11, 12, and 14, which was example 3, and 2021, which was what we just did, example 4. So example 1, example 3, and example 4. Now, even though you don't have to do it, example 19 would be a good word problem to just look. I'm going to actually talk about that later. Don't worry about 19. Just go ahead and do these. That's it. This should take you 15, 20 minutes tops. If you have any questions, let me know. We'll set up a video call. Otherwise, I'll see you tomorrow. Remember, Wednesday and Thursday are going to be practice days, and Friday is going to be the test. If you guys don't have class with me on Friday at a particular time, please let me know, because we're going to have the exam at the time of the class on Friday. If we don't have class on Friday, it will be moved to Monday. So go ahead and let me know. I'm going to go ahead and ask a couple of you to see what time class is on Friday. Again, no class on Friday. We'll move it to Monday. If you have any questions, let me know. Tomorrow, we're going to finish 8.2. Then Wednesday, Thursday, review for test. Have a great day.